Okay, so this last part of section 10.4 deals with something called rationalizing. And to be honest, we normally rationalize the denominator, but there could be times you want to rationalize the numerator too. So the first part is, what the hell does rationalize mean? It means one thing in English. Some of you guys might know what it means in English. That's not what it means in math. Remind me what an irrational number is. Give me an example of an irrational number.
4/3.
No. That's rational. Right? Because what's a rational number will be a ratio. Something can be written as a ratio of two integers, where the bottom's not zero. Right? So what the heck would an irrational number be? Yeah, well, no. That's not real, so it wouldn't even be irrational. They still have to be real. So square root of 2 is irrational. Write that as the ratio of two integers. You cannot. So there were whole civilizations of people that didn't believe in rad 2 for that fact, right? But now we know rad 2 exists, right? When you draw a number line, I've just drawn my line through an infinite number of points, not just these points, but there's all the points in the middle, and not just the fractions either. Since that line is continuous, it picks up every, it's crazy, all the numbers between 1/2 and 1/3, and then all the numbers, oh my God, it's every single one. Shit. So you get all these guys too. So square root of 2, pi, stuff like that. But like, especially square root. So obviously, radical numbers that can't be simplified. Like square root of 4 wouldn't go up there because that's just another representation of 2. And that's rational all day long. So an irrational expression would be something like square root of x, 5th root of ab, 4th root of x minus y. Those are all irrational expressions because you can't simplify the radicals that they have, right? So when I say rationalize the denominator, that means the denominator starts off like this, 1 over the cube root of x. So not only is it on the bottom, that's bad enough, but it's also irrational. So I was like, okay, well let's just rationalize the bottom, please. Make that a little bit better. So I kind of prepared you for this before, but an earlier problem where it was a 4th root of y, there was a 4th root of y cubed, so I gave that thing what it was missing. So think about it like that. In fact, I don't call it rationalizing the denominator, I call it completing the root. What do I mean by that? Well, the root needs how many things inside? How many do I currently have inside?
One.
So how many do I have to give it? All right, now was that hard? No. Now, we got to realize what we mean by give it to. Why won't this do what I want it to do? Can that go inside? No, they both have to be cube roots, right? So I multiply by the root of what I'm missing. Why am I allowed to do that? Because I do it to the top and bottom. Now the top's going to become gross, but the bottom's going to be much nicer. And for some reason, that's a good place to be. And not always. That's why I said you can also rationalize the numerator. There are certain times you want to do that, especially in calculus. You run into a lot of situations where you want to do that. So what do you end up with? On the top, I'll do the top. Give the cube root of x squared. Yay. On the bottom, we constructed it to come out nice. You get the cube root of x to the 3rd power, and what is that? Yeah, cube root of x cubed is x. So we've rationalized the denominator. Now please understand that x itself could be a square root, but as far as just variables themselves, that has been rationalized. There's no explicit root on the bottom. Okay, let me stop there. So how would our work have changed if that would have been a 5th root? We would have done 5th root of x to the 4th because we would have needed 4 more x's. Is that whole idea difficult? No, don't make it more than it is. let's see, that's example 1. Let's do example 2. What if I had the cube root of a over the cube root of 2b squared? So the instructions say rationalize the denominator. Right? So what is the denominator missing? It's missing a b, and it's missing good. It's missing 4. It's missing 2 more 2's. Right? So it only got 1 2, so it needs 2 more 2's. It's got 2 b's, so it needs 1 more b. That's why I call it complete the root. Make the inside match what this wants. We're allowed to because we're going to do it to the top and the bottom. So whatever I do down here, I need 2 more 2's and a b. I got to do up here. The cube root. So the top, you just get what? On the bottom, we designed it. Some of you guys will be able to just get there. We designed it so it's going to come out to be 2b. So if you want to see it, it's the cube root of 8b cubed. But of course, that's just going to be cube root of 8 is 2, and the cube root of b cubed is b. Now, what really makes me kind of cry a little bit is somebody does all that work. It's beautiful work, fantastic. All right, God, I sound like a president right there. It's beautiful. And then they kill the bees. Now, why can you not do that? Why can't I kill those bees? There's one on top, one on the bottom, Jeff. No, there isn't. Why can't I kill the bees? Yeah, it's a cube root of b. They're not under the same root, so you can't combine them. You can't, in this case, cancel them. All right. Okay. So here's a more interesting one. What you got, Jeff? I don't know, Jeff. Let's not make it an X. I don't want to get all freaky with the X's. There we go. Now what you can do to make this simpler, more direct, is expand the idea. Why did we give this guy 1 more b? Because it needed 1 more b so that it would be 3. Why is 3 desired? Because 3 goes into 3. That's 7. So how many y's is it missing? You might think, well, it's got too many y's. No, it doesn't. I want that to become a number that 4 can go into. That's the more general idea. So how many y's is that missing? 1. Do you guys see that? Now you could waste time and try. 4 goes into 7, 1's with 3 left over, and you write it that way, and it just looks freaky. Screw that crap. Just deal with a multiple of this, so you can do it. Now, what's this need? Do I need 3 more 27s? Dear God, no, right? Because what's 27 already got in it? 3 3s. So I need 1 more 3, 1 more y. I love it. So multiply by what? 4th root of 3y. So on the top I get somebody said. And then on the bottom you get 4th root of 81y8. But what's the 4th root of 81? 3. 4th root of y8? Y squared. And the top is just a bunch of crap. You just got to sit there. Because you can't do anything with it. Okay, I like it.
What's the 3 for?
So, what's 27? Break it up.
3 times 3 times.
How many 3's do you have?
3.
How many do you need?
4.
So we gave it 1 more 3. That's the whole idea. That's it. How many does it have? So how many more does it need? Give it to him. Why is it legal? because you're doing it top and bottom. Right? I like the look. Well, I'll take it. It's a reaction. I'm getting some people going, oh. I'm like, oh my God. Yes, that's a
When you
reaction.
change the bottom to a Y, are we going to get to a situation where the top and the bottom?
Yeah. I mean, so coming back, if it would have started off like this would have been kind of silly, to be honest, and that's one reason why I backed off. If I would have left this long, the first thing I could have done is cancel an X out, right? But it's sort of going backwards, because then the bottom would be X to the 6, it needs 2 more X's. So just leave that dude and give it 1 X in the first place. I mean, so it would have been, that's why I didn't want to do it here, because it would have just gotten in our way a little bit. But if the problem was this, you see now, if I cancel 1 X out, why am I allowed to do that? They're both 4th roots. If I cancel 1 X out, the bottom doesn't need any more. It's got exactly what it needs. So, I mean, in that case, yeah, that would make sense to go ahead and kill those. Yeah. All right, now here's the next level to this. So far, nice, right? And let me show you. I used to start with this example because it's the easiest example. If I have 1 over square root of 3. Yeah, square roots, you just multiply by what it is. Normally, if it was a 5, it needs another 5. If it was a 7, it needs another 7. I mean, but if I start with this, then people think everything is that way. I'm going to multiply by the 4th root of 27y to the 7th because Jeff said I multiply by whatever's there all the time. Jeff never said that. Holy shit. The only reason the square roots work that way is because I need 2 things. It's always going to have 1 thing already. Does that sort of make sense? So yeah, then I would multiply square root of 3, square root of 3. So go square root of 3 over 3. I love it. This idea, if any of you are going to take pre-calculus next, you're going to be doing a lot of this. Or, a decent amount of this, to be honest. Actually, for the rest of your math career, it's going to come up at some point. So, that's this level. Let's go to the next level. Whole another level. So it's still say rationalize the denominator. So what if I had this? Here's an interesting dilemma.
Can you just multiply by the square root of 2 minus square root of 5?
Let's try it. So I got a pretty good suggestion. Just multiply it by rad 2 minus rad 5. But then you'll get 2 minus rad 10 minus rad 10. So minus 2 rad 10. So now we see what we should do maybe. Do you guys remember what we did earlier where it was completely irrational times completely irrational became rational if I make these like a difference of squares pair? Because then the middle irrational goes away. So what do you end up with on the bottom? Rad 2 times rad 2 is 2. Minus rad 10 plus rad 10, gone. Negative rad 5 times rad 5 is minus 5. And on the top I get 4 rad 2 plus 4 rad 5. So I get 4 rad 2, plus 4 rad 5 over negative 3. And you can put the negatives on the top, whatever though. There's basically nothing really else you could do. Right? Nothing simplifies. So the problem is, if I try to multiply by rad 2, it'll do something here but not here. If I try to multiply by rad 5, it'll do something here. So I need to multiply by both of them, but in a smart way. So what we actually call this the conjugate of this. The conjugate of a binomial expression is just the same thing with a different sign in the middle. So whenever you factored a difference of squares, you wrote conjugate pairs. Holy shit, Jeff. It's just another word. So this is just the conjugate of this because it's got a different sign in the middle. Later we'll look at things called complex conjugates. It's the same damn thing. Let's see. Let's look at this. Let's see if you guys can handle this. So I'll rationalize the numerator. Let's see what yeah, doesn't matter. All over 3. Well,
The square root x plus square root x.
yeah, good.
Plus 1.
So this idea of conjugate, you multiply it by square root of x plus square root of x plus 1. Top and bottom. Right? So I'll do the bottom. Thanks, Jeff. And what do you get on the top? You get x. And then the middle terms cancel, right? That's how we design this. How it's always going to be when you do a conjugate. And then you get minus, what's rad x plus 1 times rad x plus 1? X plus 1. Yeah, so you get negative 1 over 3 rad x plus 3 rad x plus 1. Nifty. All right, cool. I like it. Okay. Let's see if they throw anything else at you. No. Okay. So just to make sure you see this before you do the homework, what do you think you do with this one here? Let's go back to rationalize the denominator. 2 over 5 cube root of 4. So it's a cube root. It needs 3 things inside. I know there's 1 4, but that's not the right way to look at it. What's inside the cube root already? 2 2's. So it needs how many more 2's? 1. That 5 ain't doing anything to me. It's already rational, so I don't even consider it. This is the part that needs help. So you multiply it by the 2 it's missing. So now I get 2 cube root of 2 over 5 times the cube root of 8. But what's the cube root of 8? 2. So 5 times 2, those 2's cancel. So you get cube root of 2 over 5. There's an example of something that actually cancels. Right? So it's not impossible to get something that will cancel between the two. It's just got to be legal. These both have the same root, namely none. So I'm allowed to kill them. I like it. So that's section 10.4. Make sure I didn't forget anybody. Blah, 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 blah. No. Okay. Sweet. Yeah, okay, good. So just a little bit, we're going to do just a little bit out of 10.6, and then we're going to leave nice and early, like we've gotten used to doing. That's right, Dean. In this case, my Dean watches this. I want to make sure he knows that I know. So, this is where we finally get some examples that I can compare to stuff we've done before, make a wider, more broad idea of how to solve equations. Let's start off with the really simple stuff. So the next section we do is 10.6. 10.5 for some reason was not in our curriculum. So 10.6. How do you think you would solve this equation? So yeah, exactly. How do you solve any equation? How would you solve this equation? Multiply by 7. how would you solve this equation?
Divide by 4.
Divide by 4, right? And so forth and so on. So what do I keep doing? The opposite of the operation that's making my x not by itself, right? So this stupid square root is there. So we attack both sides with the opposite of that, of course. Always. So I'm going to square both sides. So get x equals 9. Now, check it. Square root of 9 is 3, check. Now, why do we waste time checking it? It's not a waste of time, especially when you start getting more variables hanging around. Here's a really basic example of something that you want to check. I mean, if you just sort of blindly do this problem, you get m equals 1. Is the square root of 1 equal to negative 1? No. So from the very beginning, that was a bogus equation, right? Square root cannot be negative. So you got to be careful. I check first to make sure there's even a reason to do it. Okay, I like it. So, what about this problem here? Yes, please, dear God. I need to stop seeing stuff like this. What would you tell somebody if you saw them doing this? Like, what's going on? I didn't get the same answer. What would you tell them? Don't do that. No, why? Why not do that? Why am I not allowed to do that?
There's no 5 in the first part.
Yeah, there is no 5 here really, and it's stuck in the square root, right? So I can't. If I do this, then I get rad 2x minus 5 with a plus 5 on the outside. I mean, I can't put those together, right? So it's exactly, notice how that's very similar to this, right? I can't just add 5. I have to actually apply the idea of absolute value first, right? My 2 cases, and then I can do it. So here, what do I do to both sides? Square. So I get 4, cool. Add the 5, divide by 2, you get 9 halves. Cool, and if you check it, twice 9 halves is 9. 9 minus 5 is 4. Square root of 4 is 2. Check. So obviously, if that would have been a negative 2, you shouldn't do any work. You should just say, not possible, no solution. I love it. I love it. Okay, so then what about this? Yeah. So remember, when we had this, we have to add something, get the absolute value by itself. So this, I always think about this as I'm teaching you how to be a good tyrant. You have a radical element, you isolate the radical element, and kill it, right? So that'd be a good, oh, another radical element, oh, die. And then another radical element, die, right? Not bringing any moral judgments in. In mathematics, thankfully, nobody has to die. So you isolate the radical. Because if you think about it real quick, if I squared both sides now, do you see how that would so desperately suck? You can't just go square this, square this, square that. No, you square this side, I have to FOIL it, and then I still got radicals. So I made more radicals, made everything bigger, and I didn't kill any radicals. What the shit was that? What good was that? Not a good tyrant. So add 7. Thankfully, that makes it positive on this side. And then you square. Drop the square bomb, right? Kill that radical element. So you get x equals negative 3. And this is where some people just kill it automatically. But I mean, negative 3 plus 4 is 1. Square root of 1 is 1 minus 7 is negative 6. So don't just say it can't be negative. No, the inside can't be negative, and plus 4 is on the inside, so it ends up being positive. So don't just kill all the negatives, poor little negatives. I like it. So here's one more here. And I'm going to give you several to try. Now here's an example of one that you desperately have to check. This is one that I have to kind of be careful with how I make this. Let's see. Yeah, okay. Sorry, let's see. Yeah, that'll work. All right, is that gonna work? Yeah. Yes, okay. Now, one thing I always love is when people put these together and make them cancel. And somebody had a really good idea. The square root symbol kind of sucks. And he said, why don't we put a back wall in that square root symbol so I know what's really in there? I'm like, that's kick ass. I don't know whatever happened. He never got back to me. He was supposed to write a note to the Mathematical Association. Say, I'm not going to take credit for that. You write that. I never heard anything. Anyway, I think it's a really good idea. So what do I do first?
Subtract 1.
Yeah, subtract 1. So I get 2x minus 7. And then you square. Can you tell if this is negative or positive? That expression. Over here, if that, if that was a negative 2, I could have stopped because I can see it's negative. Is this negative, this expression?
No.
All right. Really? How do you know? What if x is 1?
Then yes, it is.
Oh, okay. So you can't say no and you can't say yes.
What about
It's sort of like a Schrodinger's cat kind of situation. Huh?
what about the square? Does it make it?
No. I mean before that.
Oh.
I mean, if this is my problem, I'm not going to do shit. You with me? No solution. Done. Because I can tell. But if this is my problem, can I tell if it's negative or positive? No. That's why when I solve these, I might get some x answers that don't work because they're the ones that make this a negative number. I just didn't know that when I'm like, is this negative? I have no freaking way to do it. So I do it. Math gives me all kinds of shit. So here you go, buddy. You did some weird shit up here. I'm going to give you some weird shit. We got to go back and check it. So let's keep going here. So we square both sides. I'll do half of it. I'll do this side. Whee.
4x squared is 49.
Yeah, so 4x squared. Be careful now. How do you do that correctly?
Plus 49.
Yeah, you got to write it twice. Foil it, right? So you get 4x squared minus 14x. Minus 14x is minus 28x.
49.
And then plus 49, I like it. And now what do you do?
Factor.
Minus 2x.
Not yet. You don't factor in. You subtract and add and then get it equal to 0, right? Oh, see that? Oh. So you're never not in that section anymore with anything. We've learned a tool. We can use it whenever. We're not in the screwdriver section. Why do I need a screwdriver? No, it's a freaking tool we can use whenever we need to. Right? So you're never out of that section, so I'm not going to do it. No. It's a square. I better get it equal to 0. Subtract 2x. About 30. And add 1. Anybody notice something I could do here that would make this side a little better?
Biggest common factor.
Yeah, take a 2, just divide both sides by 2, right? That's a little bit better. Now, how the hell do I do this shit? Everybody's like, we're not in the factoring section anymore. Okay. It's too damn bad.
Sure, 5.
Yep, so 2 times 25 is 50. Factors of 50 that make negative 15. That should be pretty obvious. Negative 10, negative 5. Let me see if you guys can get this. I mean, you know how to do it from there, right? You with me? Now watch. Let me show you what I do. Right? I need a negative 10 and I need a 25. I need a negative 10, negative 5. See how I had 2 right there? 2 times something I needed to be negative 10, so 5. There's my 5 and 5 for 25. I get my 10 right here. It's supposed to be negative, and the other thing's supposed to be negative. Weird. But oh well, that's how I do it. So negative 5x minus 10x is negative 15x. Check. Cool. So then what do I get? I get x equals 5 or x equals 5x. I got to check both of those. So the way I made this problem was I assumed x was 5. And then I did twice 5 is 10 minus 1 is 9. Square root of 9 is 3. Plus 1 is 4. So then I made this side come out to be 4 if x is 5. So I knew 5 was going to be the answer. I also knew I was going to get a second answer because I know it's going to be an x squared thing. And more than likely that second answer won't work. It might. So see, I know the 5 works because I get, here's 1 is 4, 10 minus 6 is 4, check. When I throw a 5 in, it works. What about 5 halves? 2 times 5 halves is 5. 5 minus 1 is 4. Square root of 4 is 2. And on this side, I get 2 times 5 halves is 5 minus 6. So I get 3 equals negative 1. You guys with me? I'm just throwing 5 halves in and checking it. Do I get a true statement when I throw 5 halves in? No. So it's shit. And look right here. 2 times 5 halves is 5. Minus 7 is negative 2. That's the x value that would have made this number negative that we know would have been a bogus equation. There's just no way to know at this point, is there? No way. So math gives me the answer. When I square something, I lose information about if it was positive or negative. What's 3 squared? 9. What's negative 3 squared? 9. So if I said, what did I square to get 9? You can't tell me for sure. Right? Do you guys see what I'm saying? So when I square, I lose information about if it was positive or negative. Math gives me all the answers to this question. And some of them don't work for this. Because when I squared it, I changed it. Okay, maybe you guys understand. Because it's frustrating when the math is difficult. And then as a student, I'm sure somebody's got to be like, I did everything right, and it gave me a stupid wrong answer? Screw this shit. Right? So I understand that feeling, but I want you to understand that this is the only way math can work with you. All right, you do that shit, here's some stuff, you better go back and check. Because when you did this, math lost information. It didn't. It's just got to work with what you got. So hopefully you guys understand. So what do you get out of all this? With radical equations, you got to check your answers. That's what you get out of all that. So the answer is just 5. Cool. I like it. And really, if you remember how we put this into y1 in the calculator, and we put this into y2. So this would look fundamentally something like this, and that would look like a positive slope. So it could have one answer. Now, it is possible for it to have 2 answers. It is possible for both of those answers to be good if the line hits this more than once. Does everybody see what I'm doing right now? This side would look like this, would look like a square root, and this side would be just a line. So in this case, it just hit once at 5. But it could, both of them could possibly be true. It just has to hit twice. It is possible. But more than likely, one of these won't work. Okay, let me see. Do it about. Anything else weird in here? Oh yeah, that is truthful. Let's see. Yeah. Oh, well, let's do one of those and then we'll call it a day. How early of a day is today? Ooh, today's really early. Oh, shit. I think we'll be okay, right? So, amazingly enough, what do you guys think you would do with this? Let me see if you guys are cool with this. Subtract 2, isolate the radical. Yeah, why do you not stop here and say no solution? Why do you not stop here and say no solution? Cube root. Sweet. Now you start to realize why I really pounded. Odd roots, completely cool. They're not going to have anything freaky. Even roots, oh shit. If it's negative, I stop and all that kind of shit. It's a cube root. It can handle this. So then you cube both sides, because that's the opposite of a cube root. So you get 1 minus 2x equals negative 27. Subtract 1, divide by negative 2. Yes?
So what if it was squared? What would happen?
If it was a square root, I would have stopped right here, because the square root can't be negative.
Okay.
But odd roots, so even roots can't be negative. Odd roots all day long can't be. And that's really just because when I have an odd number of things, it keeps the sign of the numbers, right? When I have an even number of things, it's always positive, well, real numbers. And there is one little extra weird thing in there, but I'm not going to do it today. Why not? I haven't given us a really early day yet, have I? We do have, we do have that section 10.7. Let's see, and on tomorrow we've got the quiz first. All right, so just to make me feel morally better, let's do one more problem. Even if I didn't say I was going to, I don't care. I'm going to do one more problem, make me feel a little bit better, because we're a little ahead, which is pretty awesome. Because complex numbers, if you've never seen them before, will take a little bit of getting used to, obviously. And I do want to show you that video too. We'll see what you think about it. You're going to make one up, Jeff? Okay. Let's see.
This is another section?
It's going to be exciting, huh?
This is another section?
No, same section. Let's see. Oops, sorry. Yeah. How many radicals do you see in there? 2. So when I had one radical, I had to square once. So you should kind of expect, if I have 2 radicals, I have to square twice. Because there's no way in hell you can kill both radicals with one fell swoop. You can't. Now, one thing I do recommend is to at least get the radical elements away from each other so they can't help each other out. Right? Just to kind of continue our tyrant thing, right? So if I add that over, I've isolated one of my radical elements, right? Is that cool? So I've done the best I could. And now what do I do to both sides? Square. Well, what does that mean for this side? Let me just go ahead and write it both. Square that side means FOIL it out. Oh, shit. So I'll do this side. Okay, there, it did happen. Now you start to see why I'm going to have to expect to square twice. Because what is square root of x minus 2 times square root of x minus 2? X minus 2. And then I get 1 and another one. I get 2 square roots of x. I still got a radical element running around. Right? And then I get plus 1. Okay, so that's the foiling of that side. Again, the FOIL process doesn't give a shit that it's a little bit longer than normal. Just multiply all this stuff out. Everybody gets a turn. So now, what do you think I do? Exactly. I pretend like that's where I start. Doesn't matter how I got here. That's where I am. I isolate the radical element, and then I kill it. Right? So thankfully, the x's go away. That's nice. And I get the 1's go away. I can add 2 over. Now, to be honest, I don't have to make fractions. Can you imagine if that was a 7? I don't have to. I can just square both sides right now. But right now, I mean, those obviously, they divide into each other. So I divide by 2. All right, let me stop there for a second. Can you imagine we started here and now we're here? Well, that's crazy. That's awesome. And now, of course, what do? Yeah, square both sides. So you get 1 equals x minus 2. So I get x equals 3. It's crazy. And then you better check the shit out of this, because we squared twice. We might have introduced all kinds of funky-ass things. So we put it in here. This is how I made the problem, by the way. 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 is 1. Square root of 1 is 1. 2 minus 1 is 1. Check. Crazy. I like it. And that's plenty, man. We've done plenty. So enjoy today, man. You're out of here early. Unless you have another class you got to wait around for now. I'm sorry. somewhere and sit. Or find a nice air-conditioned spot to hang out. So don't forget, first thing tomorrow, quiz on systems of three equations without matrices and with matrices.